In this video I'm going to show you the capture-recapture technique, which is a method that allows us to quickly estimate the size of a large population. So for example, the number of squirrels in a wood, it is not particularly practical for me to be able to go round and capture every single squirrel in the whole wood and then count them up individually. Similarly, the number of people in a town centre, it's not practical for me to go around and count them all up one by one, or to group them all together and then count them. It's inconvenient. The number of sweets in a jar, it's going to take me a very long time to count them all individually. So I'm going to use this technique to allow me to get an estimate for roughly how many squirrels there were in that wood, or how many people in the town centre, and so on. This is the technique. I'm going to talk you through it, and then I'm going to show you an example where it will hopefully make more sense. So the first step is to select or to capture some of the objects, whatever they are, whether they're squirrels, people, sweets, whatever they are, and then mark them in some way. Then you write down the fraction of the total population that you have marked. Step 2, you put them back. You put them back into the large population. You release them and allow them to be mixed up. Step 3, you recapture some of them, and you count the number of those that have got a mark on them, the same mark that we put on to begin with. You can then write down the fraction of them that are marked. And as long as nothing has changed to the population in between step 1 and step 3, these proportions should be the same. Therefore, we can make our fractions equal to each other and solve to work out the estimate for the total. So that might not make sense written like that, but hopefully it will make sense in this example. I've got a large bowl of pasta here, and for some strange reason I would like to know an estimate for how many pieces of pasta there are in this bowl. Now I'm obviously not going to count them all up, so what I'm going to do, step 1, I'm going to select some of them, I'm going to mark them and write down the fraction of all of them that are marked. So I've got my pen here, I'm going to select, I don't know, let's do 10, I think, to begin with. So let's, so 5, 6, 7, 8, 9, 10. Is that 10? Yep, so I've got 10 pieces of pasta there. I'm going to put a mark on them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have marked 10 pieces of pasta. I am now going to write down the fraction that are marked. So there's 10 pieces of pasta that are marked out of all of these pastas that are in here, all of the pastas all together, which I don't know what that is. That's actually what I'm trying to work out. So I'll call that N. So 10 pieces out of all of this pasta have been marked. Step 2, I'm going to put these back into the bowl and I'm going to mix them up, give them a good mix up. There we go. Next, I'm going to do step 3 now. So I'm going to select a number of pieces of this pasta. I'm going to select, I don't know, let's say 20, doesn't particularly matter. So if I select 20 pieces here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 pieces of pasta here. And I want to know how many of these have got a mark on them. So let's just check them. No, 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 no. I hope one of these has got a mark on them. No, no, nope, no. Oh, there we go. That one does. So we've got one of them so far. No, no, No. No. Okay, so 1 piece out of the 20 has got a mark on it. So the fraction is 1 out of 20 that has got a mark on it. Now, as long as I didn't do anything between step 1 and step 3 to change the population, which I didn't add any new pasta into the bowl, I didn't take any pasta out, I know that these proportions are the same. So I can now say that the fraction at the beginning is equal to the fraction at the end. And now I can just rearrange this to solve and find out n, the total number of pieces of pasta in that bowl. So if I times both sides by n and times both sides by 20 at the same time, so if I times both sides by 20 and times both sides by n, so I've just moved the n over here, moved the 20 over there, and I get that 10 times 20 is 200. So according to my little my capture recapture technique here, I have estimated that there are 200 pieces of pasta in this bowl. Right, let's look at another example. A written example here now, no pasta involved. A group of students want to estimate the number of fish in a pond. They catch 45 fish and mark them. They put them back. The next day, they catch 60 fish and finds that 18 of them have got a mark on them. I want to estimate how many fish live in that pond. So, first of all, let's write down the fraction of the fish that were marked on day 1. So they caught 45 of them and put a mark on them. So 45 out of all of the fish have got a mark on them. The second day, they caught 60 fish and 18 of those fish have got a mark on them. So the proportion of fish on day 2 that have a mark on them is 18 out of 60. And as long as nothing has changed from day 1 to day 2, and I'll talk about what I mean by that, by as long as nothing has changed in a moment. As long as nothing's changed from day 1 to day 2, then these proportions should be the same. The fraction of fish that have got a tag on them, a mark on them on day 1, should be the same as the fraction of fish that have got a tag on them on day 2. Now I'm going to rearrange and solve this equation. So I'm going to times both sides by n and times both sides by 60. So move the 60 up here, move the n over here. Now I'm going to divide both sides by 18 to make n the subject. So if I divide both sides by 18, I get this. And if I type that into a calculator, I find that there are 150 fish in that pond, according to my estimate. Now, like I said, this, when I'm saying that nothing has changed to the proportion of fish overnight from day 1 to day 2, I'm assuming that these proportions are the same. And they might not be. For example, some new fish might have been born overnight. That's going to change the total size of the population, which might mean that the proportions would change. Or alternatively, some of the marks might have worn off overnight. For example, we might have tagged some of the fish on day 1, but on day 2 it might have rubbed off and actually it's not visible anymore. So these are external factors that might mean that this assumption that the proportion of fish on day 1 that have a tag is not the same as the proportion of fish on day 2 that have a tag. So we're assuming that the proportion remains the same, that the number of marks and tags haven't come off, or the population size hasn't changed. There haven't been any more fish that have been born, or none of the fish have died, or anything like that that might change the populations. So these are our assumptions that mean that these two things are the same. So there we go. That's how we use the capture recapture technique.